Okay. Lesson number 8 looks at an infinite geometric series. So David buys a pizza. He eats half the pizza, then half of the remaining piece, then half of the remaining piece, etc., etc. Continuing in this way, would he actually ever finish the pizza? In theory, would he ever finish the pizza if he's only eating half of the remaining slice each time? No, because there would always, or explain in practice why this could not happen, is because there would always be half a remaining piece left. So it says, represent this situation with a geometric series whose first term is half, meaning he ate half the pizza. If he eats half of the next slice, what fraction of the pizza would that have actually been? So he's got his pizza, he's eaten half of it, and then he eats half of the remaining piece. That would be a quarter. So he's eaten this, he's eaten this. Now he eats another half of the remaining slice, which would be an eighth. If he eats half of that, what fraction of the pizza has he eaten? A 16th. And so on. So if we were to use this series and find a formula for S of n, the value of A, or my first term, is 1/2. What's my common ratio? It's also going to be a half. So S of n, which is A times R to the power of n minus 1 divided by R minus 1. Gives me 1/2 times 1/2 to the power of n minus 1 divided by 1/2 minus 1. What is 1/2 minus 1? Negative 1/2. So I'm going to put that there just because I need more room. And if I take 1/2 and I divide it by negative 1/2, what would I get? But what about the negative? So I'd get a negative 1. And if I multiplied this negative 1 by the two terms inside the brackets, this negative 1 would become positive, and this 1/2 to the power of n would become negative. So I could rearrange it to put my 1 first because it's now positive. And my 1/2 to the power of n would then be negative. So it says, use the table feature of the graphing calculator to complete the table to 3 decimal places. So on your calculator, what you would do is let y1 be equal to 1 minus 1/2 to the power of n. And then instead of pressing the graph button, what you would do is press the second button and the graph, which is actually table. And your calculator will give you a table of values. It should have x's and it should have y's. So when x equals 1, y equals 0.5. When x equals 2, y equals 0.75. Which is the 1/2 plus the 1/4. and so on. So fill this chart into 3 decimal places as you go along the line. And then you're going to plot the points on the grid. So as my value of n gets larger and larger and larger, what number does the sum equal? Or what number does the sum get closer and closer to? 1. This is called a convergent series. It's called convergent because the sequence of sum converges on to an actual value. It would appear that if we added the terms of the series indefinitely, we get closer and closer to the value of 1. So we could say that the sum of an infinite geometric series, 1/2 plus 1/4 plus 1/8, if I continued on infinitely to like a million plus 1, infinity plus 1 terms, that number is going to get closer and closer and closer to equaling 1. When we are using an infinite series, we can use the symbol S with no subscript, or we can use the infinity symbol to indicate that it's the sum of an infinite number of terms. The sum of finite numbers of this term will never actually equal 1. So if I told you to add the first 1,000 terms, it's not actually going to equal 1, but it'll be so close to 1 it actually is. So explain with reference to the pizza why the sum of this series would be 1. Because what's eventually going to happen? You're going to eat the whole pizza. Because you're not actually going to be able to physically cut half a slice anymore. So you're going to eat the whole pizza. Would be like if I started from here and took a step that brought me halfway closer to the door. So if I was able to take just one step and get halfway closer to the door, halfway closer to the door, halfway closer, in theory, I would never actually reach the door. But in reality, I am going to reach the door because I'm no longer going to be able to take half a step because it's going to be such a small number. Okay, so let's look at the next series. Consider the infinite geometric series 2 plus 4 plus 8 plus 16, etc., etc. If we determine the values of a and r and find a formula for s of n is a times r to the power of n minus 1 divided by r minus 1. So in this series, what is the value of a? 2. What's the value of r? 2. 2 to the power of n minus 1 divided by 2 minus 1. What's 2 minus 1? Okay. So then I would get this for my formula. 2 times 2 to the power of n minus 1. Put that equation in to your calculator for y1, and let's do the table feature again to find those values. Rather than having to type it over and over and over again, it just makes it go faster. First 3 terms should be 2, 6, and 14. Does that seem right?
Yep. Should be 2, 6, 10, 14.
No, not 2x, 2 to the power of x. You have 2 times x's. What you guess? So again, if we plot this point on the grid, first term is 2. Oops, a little bit large for 2. Second term was 6. Third term was 14. Fourth term was 30. Fifth term, 62. Sixth term, 126, which is actually off the graph. And then I can't plot any of the other ones. This is called a divergent series. It's called a divergent because it doesn't converge to a single value. It just keeps getting bigger and bigger. Which means if you ask me what the sum of the infinite series is, I wouldn't be able to tell you. Because infinity is not a number, it's a concept. So to think of infinity, think of the biggest number that you can count to and add 1. That's infinity. So when you used to have the teasing games, I hate you, well I hate you more, well I hate you infinity, well I hate you infinity plus 1, that's how you win the game. It's always infinity plus 1. So this would be a divergent series because I could never find the sum of this. You give me the sum to the first gajillion numbers, and I'm going to say, well, I can find the sum to a gajillion and 1. And it's just going to keep getting bigger and bigger. So an infinite geometric series that has a ratio of 1/2 converges to a particular value, and it's called the sum to infinity. An infinite geometric series that has a ratio of 2 is called a divergent series, and it does not have a sum to infinity. So this is the last thing that I'm going to leave you with before we go into the examples tomorrow. Is this investigation. What I want you to do is to complete these 3 charts. So this looks at all of the values that are less than -1. For example, if r is equal to -2. This looks like at all of the r values that are between -1 and 0. That's what this is. R is less than 0 but greater than -1, such as -1/4. In this column, we look at values that are between 0 and 1, such as 2/3. It could be 5/8. It could be 7/6. Not 7/6. 7/8. It's something between 0 and 1. And then we look at R values that are greater than 3. What I want you to do is to complete the table of values. So, -2 to the power of 1 equals -2. -2 squared equals 4. And so on. Okay, so yesterday we were looking at our common ratio values of r to the power of n as we approach infinity. So we looked at 4 different examples. We were looking at examples when my r value was less than -1, such as if it was equal to -2. And I asked you to complete this column on your own. So what you would get is -2 to the power of 3 is -8. -2 to the power of 4 is positive 16. -2 to the power of 10 becomes 1,024. To the power of 20 is 1,048,576. And to the power of to the power of 100 becomes 1.3 times 10 to the power of 30. If I look at the next column, that was with my r value equaled -1/4, so between 0 and -1. If it's raised to the power of 1, I get for an answer -1/4. Raised to the power of 2, I get 1/16. To the power of 3 becomes -1/64. To the power of 4 is 1/256. And then when I get to the power of 10, 20, and 100, I start getting scientific notation. So to the power of 10, I get about 9.5 times 10 to the -7. To the power of 20 is 9.1 times 10 to the -13. And to the power of 100 was 6.2 times 10 to the -61. Maybe I should make that look like a power better. Then if I looked at having an r value between 0 and +1, such as 2/3, to the power of 1 is 2/3, to the power of 2 is 4/9, to the power of 3 becomes 8/27, to the power of 4 becomes 16/81, to the power of 10, I get 0.173, and it goes on. I don't necessarily have to put that as a fraction. To the power of 20, I get 3.0 times 10 to the -4. And to the power of 100 becomes 2.5 times 10 to the -18. If I look at the last column, and that's r values that are greater than 1, such as 3. 3 to the power of 1 is 3, then I've got 9, 27, 81, to the power of 10, 59,049, to the power of 20 becomes 3.5 times 10 to the +9, and to the power of 100 is 5.2 times 10 to the power of 47. So the last thing that I asked you to do is whether or not you could fill in these 2 statements. So we talk about convergent and divergent. So convergent means it converges onto a value. As the power of n becomes larger and larger, my r to the power of n starts to become closer and closer to the same type of number. So which sequence converges?
The -1/4 or the 2/3.
So the -1/4 and the 2/3. And then divergent series are the ones that just keep getting either really, really small or really, really big, and they just never seem to have an end point to them. And that happened when r equaled -2 or when r equaled +3. Because this number right here, this is a 5, then 2, followed by 46 zeros. A very large number. Whereas on this side, this is 1, 3, and 29 zeros. 101, if it was to the power of 101, I would get a negative value. So this series right here goes back and forth. I have a positive and then a negative, positive, negative. Those are my values all the way through. But the values just keep getting either extremely large in the positive sense or extremely small in the negative sense, meaning that negative 1 point something times 10 to the power of 29 is going to be a ridiculously small negative number. So as n gets larger and larger, the power of r to the power of n gets closer and closer to 0 when that r value is between positive and negative 1, or I can say if the absolute value of r is less than 1. So meaning it could be a positive value or a negative value. But this is probably easier for us to just think of it. The r value is between 1 and negative 1. R to the power of n just keeps getting bigger and bigger if my r value is less than negative 1 or if it's bigger than 1. So that helps us determine if we have a convergent or a divergent series. And we can use this rule to help us determine the formula for the sum of an infinite geometric series, and that's on the next page. So the sum of an infinite series is the first term plus the second term plus the third term plus the fourth term up to an infinite number of terms. Or using this formula, a times r to the power of n minus 1 divided by r minus 1. We can also rewrite the formula as 1 minus r to the power of n divided by 1 minus r. That would be taking the top and the bottom and multiplying it by a negative, is what would end up happening. Provided that negative 1, or that the r value is between positive 1 and negative 1, this r to the power of n is just going to get closer and closer to 0 under this format. So if I look back on the previous page when r was equal to 2/3, 2/3 to the power of 100 was 2.5 to the power of negative 18. That's a 0, decimal, 17 zeros, and then 2 something. So it's getting extremely small. So this r to the power of n value is going to get to the point where it's going to equal 0 as I go up to infinity. So if this equals 0, I get 1 minus 0, which is 0. Or sorry, 1 minus 0, which is 1. And when I multiply it by a, I'm left with a. So the sum of an infinite series, an infinite convergent series, becomes a divided by 1 minus r. So this is a convergent series. That's what this right here. The absolute value of r is less than 1. Or the value of r is between negative 1 and positive 1. So then we have a flow chart that summarizes the geometric series. With a geometric series, I have a finite or an infinite. A finite means it comes to a stop. I have a start point and I have an end point. Find the sum of the first 30 terms. That's a finite. Find the sum of the series that has 10 terms in it. Or if the sum of the series equals this amount, how many terms did it have? Those are finite because they have an end point. Then we have the infinite. Infinite just keep going on and on and on. Find the sum of 2 plus 4 plus 8 plus 16, dot, 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 dot. That means it's going to go on infinitely. Within those series, I have a convergent and a divergent. So the divergent means that the series does not approach a particular value. So that 2 plus 4 plus 8 plus 16, on and on and on, will never actually approach a value, because if I say find the sum of the first gajillion terms, the person beside me can find the sum of the first gajillion and 1 terms. Or we can just keep getting bigger and bigger. It's like I said yesterday, infinity plus 1. So if I find the sum of the first infinite number of terms, all the person beside me has to do is just find 1 more, and they're going to get a larger sum. So in this case here, if I have a divergent infinite series, we can't find a total sum for that series. If I have a convergent, meaning that the r value is between negative 1 and positive 1, it will have a sum. And that's the formula a divided by 1 minus r, which is on your formula sheet. Okay? So let's look at a couple of examples. Determine the common ratio for each of the following geometric series and state whether a sum to infinity would exist. Calculate the sum if it does exist. So how do I find common ratio? Okay, so divide the second term by the first term. So 1/3 divided by 1 would be 1/3. Is this a convergent series or a divergent series? Convergent. So if it's a convergent series, I can find the sum. So S, if it makes it easier, you can put S of infinity, or you can just leave it as S, equals A, which was 1, divided by 1 minus R. So I get 1 divided by 2/3. And what is 1 divided by 2/3?
1.5.
Which as a fraction would be
3
3/2. So if I look at this, how do I divide fractions? I multiply by the reciprocal. So this 1 divided by 2/3 would be 1 times 3/2. Okay, if I look at the second one, to find my R value, -5 divided by 1, my R value is -5. So this makes this what kind of a series? Divergent. Does a sum exist? No. So the sum does not exist. Okay, and then the last one, -1 divided by 2. My R value is -1/2. Convergent or divergent? Convergent. So that means I can use that formula. So the sum of an infinite number of terms is the A value divided by 1 minus R, which was -1/2. What is 1 minus -1/2? 1.5 or 3/2. So again, to multiply or to divide fractions, multiply by the reciprocal. If I have 2 times 2/3, or 2 groups of 2/3, I have 4/3. Okay. Class example number 2 says the first term of the geometric series is 2 and the sum to infinity is 4. Determine the common ratio. So the sum is 4. The first term is 2. So I get 4 equals 2 over 1 minus R. How do I solve this? So a strategy I could use, cross multiply. So remove the brackets. Then what would I do? Subtract 4 from both sides. What's 2 minus 4? And then I would divide by -4. So -2 divided by -4 equals 1/2. And then the last question says, write the repeating decimal 0.07 as an infinite geometric series. So as an infinite geometric series, it would be 0.07 plus 0.007 plus 0.000, oops, got a 0. et cetera, et cetera. So if I add all of these terms together, I'm going to get this 0.0777. Repeating. What's the common ratio? I find the common ratio by taking one term and dividing it by the preceding term. So if I go 0.007 divided by 0.07, what do I get? Do I get the same thing if I went 0.007 divided by 0.007? Yeah, I get a common ratio of 1/10. Does this make this a convergent series? This R value? Yes, because it's between -1 and +1. So then I can write the sum to infinity, a divided by 1 minus r. My first term was my 0.07. 1 minus 0.1. So that gives me 0.07 over 0.9. If I'm trying to write this as a fraction, do I commonly have decimals in my fraction? No. So what can I multiply the top by to get rid of the decimals? 100. So if I multiply the top by 100, I need to multiply the bottom by 100. Because what's 100 over 100? 1. So it's not changing the value of this fraction, it's changing how it looks. And I get 70 over 90, which if you take your calculator now and go 7 divided by 90, you'll get 0.07 repeating. So the questions. Question number 1, A, C, G, and I. It's determining whether or not there's, it's like class example number 1. 2, 3, 5. Actually, I'm going to skip 5. 2, 3, 7. And then 9 to 11.